All right, here we go. It looks a little bit different, but this is still actually the same question, and we're going to use the same proportions to solve for this question, but let's read through it. To make a clay vase, an artist uses a potter's wheel that has a diameter of 13 inches and spins at 120 revolutions per minute, RPM. Find the approximate distance traveled in 1 minute by the point on the outer edge of the wheel. So here we go. We're looking through, we got a few things to notice. One is that it uses diameter here instead of radius. We need to think about, well, what is diameter? And diameter is equal to 2 times the radius. So let's just keep that in mind. It also is talking about, well, here's our circle, our potter's wheel. It's talking about revolving around 120 times per minute. So it goes that distance of the circle 120 times per minute. So that's going to be after 1 minute. How many times around has it gone? Well, it's gone 120 times. And we're going to keep that in mind as we go through. So here's our proportion, and I'd pause it, see if you can do this problem, and then come on back and see how you did. So hopefully you have paused at this point, and we've got, okay, well, one part of our proportion is going to be the times around the circle, regardless of the length. So maybe use 360 degrees. That's one that we're probably more comfortable with, and you could have also use radians here, but 360 degrees over, under theta. So the number of degrees that we'll be using, that x, that value, whatever that is, divided by 360. So part over whole equals part, and we're going to use the arc length as that's what we're trying to find out, is for that many times around, how long was that? Divided by the one full circle's arc length, which is really just the circumference. So 2 times pi times the radius. And notice on this one that this time our numerators are actually bigger than our denominators because it's going around 120 times. That's a little bit different, but it doesn't change our proportion at all. Same ideas are happening here. And so let's plug in what we know. If the angle going around 120 times, how many degrees is that going around? Well, it's 120 times 360 degrees. And you could figure that out, but notice it's being divided by 360 degrees. So I actually wouldn't even worry about that, because that's going to simplify down in just a moment as it is. Now really what we're looking for is this arc length. So S divided by 2 times pi times r. Now we don't have the radius, we have the diameter. So 13 inches. And so to get your radius, you would cut that in half. That's 6.5. But notice that you'd multiply it right back by 2 afterwards, because the circumference of the circumference equals 2 pi r. 2 pi r. But that really is equal to just pi times the diameter, because remember 2 times radius, that is diameter. But with that all in mind, we end up with pi times, either way you want to think about it, either times 13 or 2 times 6.5. And so either way, we're ending up with 13 here in our denominator. All right, let's go ahead and simplify this out. 360 degrees divided by 360 degrees leaves us with 1. And we end up with 120 equals the length that we're looking for, all the distance around, divided by pi times 13. So multiply both sides by pi, 13 pi. 13 pi. And we get 120 times 13 times pi is equal to that the distance traveled. And so we'll pull out our calculator here. Our exact length then, so 120 times 13 gives us 1560, 1,000. Oh, my pen stopped working. Just a moment, let me fix these technical difficulties. All right, sorry about that. There we go, okay. So we said 120 times 13, that was 1,560 times pi. And that would be our exact distance around, and this was in inches. So 1,560 times pi inches is that full distance traveled around 120 times back on our circle, 120 times around. Or approximately, let's go and multiply that number by pi. And 4,900, let's go 0.9. So this is approximately 4,900.9 inches. All right, hope that helped.